We have a list of, I don't know, 5 or 6 so far. Who knows how there are going to be, many there are going to be, of different worksheets titled Comparing Functions. Some are harder, some are easier. This one has more questions than any of those that I've had because I tried to put together some of the things from all of those. So I'll post this video and then I'll probably post it again 6 more times because I'm not going to make a new video every time. I might put some stuff in writing to go with it, but not. So what most of these have is 2 different functions. And remember that a function is a drawing or an equation where for every x there's exactly one y. And we're going to start with functions, but then we're going to start throwing in things that might not exactly be functions. Sometimes they'll be given as a graph, the way I did here. Sometimes they'll be given in a table, and you'll have to look at the table and try and figure out what shape it is, which might involve doing some graphing. Most of these are going to start out with questions. What type of function is it? How do you know? So I think the f of x, which is the red one here, is probably easiest because you've been working with those forever. It's a straight line. Do you remember what a straight line function's proper name is? In Mod 6, actually day 1 of semester 1 for Integrated Math 3, we talked about different shapes based on their degree, their highest exponent. I'm going to pause, write some of them out, and then I'll talk to you. Okay, I wrote out some of these things. These are things that we learned back at the beginning of the semester and partially probably in previous years. Degree 0, which means there's no variable showing at all. It could actually have x to the 0 in it, but if so, we usually don't bother to write it down. If you graphed a equation that said something like y equals 3, it would go straight across that 3, totally horizontal line. Linear, that's your basic y equals mx plus b equation. Yes, linear can also go perfectly horizontal and perfectly vertical, but generally speaking it doesn't. It has some sort of slope to it. Quadratic. Oh, you did so much quadratic stuff in IM2. Quadratic ones are parabolas. Could be an upright parabola, could be a reflected downward parabola, but those are parabolas. Cubics. We did cubics first semester here. Cubics, the first cubics we talked about were sort of like that. I don't much like that one. Maybe more like that. But we also learned that a cubic can be this. The first one I showed goes in 3 directions if you count that inflection point, that almost flat point. The next one I drew goes 3 directions. I'm saying 1, 2, 3. And it could be up on the right, down on the right. We had a lot of discussion about that stuff when we were doing Mod 5. A quartic, let me write some words. This is quadratic. And quartic is something that goes in 4 directions. The quartic often looks like a W kind of shape because it needs to go 1, 2, 3, 4 directions. And of course it could go forever. But generally those are all polynomial things. That means they have exponents that are 0 up to forever, but they're all whole numbers. They're never negative integer. They're never negative exponents. They're never fraction exponents. So if I look at f of x, yeah, that looks like a straight line. And the word for a straight line is linear. How do I know it's linear? Straight line. And I'm really going to be saying a lot of these assignments are about trying to put things in your own words. So I'm going to try to force myself not to write down so many answers, but talk about them. So that when you do them on your own, it will end up in your own words instead of trying to just come back here and copy what I wrote. It's a straight line. It has a constant slope. It continually goes up 2 and over 4. Let me look at the spacing here. Looks like every square equals 1/2. So that's up 1 and over 4. What's that slope going to be? Remember that slope equals the rise over the run. So in this case, I would say that has a slope of 1/4, except for the fact that it's not going uphill left to right, it's going downhill left to right. Downhill left to right means that's going to be a negative slope. So I could think of this as up 1 and 4 in the negative direction. Or I could think of this as being down 1 and 4 in the positive direction. Either way, you end up with negative 1/4. Those are things that you might need to say about it when you're describing how do you know it's a straight line, how do you know it's linear. Let me look at the second one, the green one. It doesn't have a definite slope. It's going up and down, isn't it? How many times is it going up and down? 1, 2, 3. That means that this one should be cubic. How did I know? Do I know for sure that it's cubic? It could be cut off on the edges. But if this is showing the main part of the graph, I would say that this is cubic. And I know that because of the fact that it goes in 3 directions like that. What else do I know about it? We're assuming that they would show us the main part of the graph. They didn't put arrows on the end, but for all these problems, since they go to the edge of the graph, we're going to assume those arrows in there. So you'd have to put some stuff about recognizing that rising and falling 3 parts to make it into a cubic. We're going to keep looking at the same graph. I'm just going to erase the marks on that graph, but then I remembered I got the same graph over and over again, so we'll look at it, the next one. The next day says, where in the picture is f of x greater than g of x? What do they mean f of x greater than g of x? Remember that f of x or g of x is like y. And when you're looking at a point, for instance, if you look at this point, 0, 1, it's telling you sideways 0, up 1. So it means how high is the graph? How high is the line or curve at that point? So I'm looking for places where the y value or the height of f of x is above the height of g of x. Again, I'm trying to get you to put it in your own words. So I'm not going to write out everything that I'm saying. So basically what it says, state in words what this means, I would say this means that the red line is above, higher than the green one. And the places where I see that happening are not there. That's so good because the green is definitely higher there. Here, because the green stuff, even though I don't see the green over in this section, the green has to be lower because the green's continuing down. In this section here, I got the green higher. That's not the section I want. Right here is good, because even though there are green parts that are higher than that, right there at the y-axis, the red's the highest part. Over here, the red's the highest part. Over here, the red's the highest part. And that's what we're looking for. When is the red the highest part? When I come over in this section, it keeps jumping me here because I touched the arrow in order to touch that. When I come over in that section, I have green is definitely higher. Even though I can't see the green out to the edge, I see where it's going. The green is definitely higher. If I was going to answer this question in writing, you would have to come up with those words yourself. I'm going to write this. Tell how you know you're correct. So I would say, if I'm talking about this section here, it's not just at a certain point. I would say, what are the x values that make that happen? And it's kind of like writing to me, which I'm going to ask you to write to me eventually. This is true when the x values right here at 2.857 when the x's are bigger than 2.857 and forever. Again, we're assuming arrows on the end of these if they didn't tell us, because it went to the edge of the graph. Then I have this other section over here I have to talk about. This is x values that are between, which one should go first? I put this less than symbol, so I need the smallest x value, which is -1, up to the biggest x value, which is +1. So it says when the x values are in between -1 and +1, that's another space where the red line, the f of x, is higher than the green line. How do you know that you're correct? And again, you're going to be talking about things like we can see that the red line is above the green line. We can also talk about all the y values in that section. Choose a few points, talk about the y values, and show that the y value on your red line is higher than your y value on your green line. The next one's saying, when are they equal to each other? So we're again talking about the f of x, g of x, the y values at that point. And I know that I've had some people look at this kind of problem and say that f of x, g of x, that this y value, let's try this, this y value on the red one is the same as this y value on the green one. And they want to write that down. They're talking about, when they say f of x equals g of x, they're talking about for what x values are they the same. So you would have to have the same x and the same y. Even though this kind of says y equals y, because they both have the x in it, you'd have to have the same x and the same y values. That's not those. Let's get rid of that. It really means, when did the two lines meet up with each other? And they seem to meet up with each other in these three places. Explain what this word means in words, what this means. What is the question asking? Basically, the question is asking us, where do those two curves or lines meet up with each other? So I would say at -1, 3.5. I would say at 1, 2.5. And at 2.857 with 1.571. I know those are the points, the places where the f of x equals the g of x, because those are the places where the two curves meet with each other. I'm looking at the domain and range. Remember that domain technical difficulty, sorry. Domain is the set of acceptable x values. The x-axis goes from left to right. So it's basically saying, how far does it go to the right and how far does it go to the left? The range is the set of acceptable y values. The y-axis goes up and down. So when they ask for the range, they're talking about up and down. They're asking us to state the domain and the range in words and in symbols. I'm going to talk to you about the words, make you put those in your own words on your assignment, and then I'm going to write it in symbols. So start with a straight line, the f of x, because f of x is easier. So the domain would be the x's and the y values. Sorry, the x values. It goes this way and this way. We're assuming that it goes forever in both directions. Every time I try and write close to the edge of my graph, I end up doing what I just did and hitting an arrow. So I guess I'm not going to be able to draw an arrow on the end of that to show you what's going on. But I need to write something about with my axis. These x values, how far do they go to the right? Forever. I'm going to write forever as an infinity symbol. How far do they go to the left? Forever. We can't just write infinity. We have to write negative infinity, forever in the negative direction. This is negative infinity, and this is positive infinity. There are certainly other ways to write that. If I wanted to write it with interval notation, I would say from negative infinity to positive infinity, parentheses, rounded on the ends, because it never touches positive infinity, it never touches negative infinity. Another way to write that is all real numbers, or this fancy R that has two legs on it. They want you to write it in words too. So if I was just going to write it in words, I would say it goes forever to the left and the right, or every x value works. If I wanted to find the range, let's do domain for the green one also first. Green one, and how far does it go? You don't see it going forever. And that looks like, oh, forever down. But can you see that it's tilting just slightly to the right? And when we come to the other end, it's tilting just slightly to the left. This one has the same exact answer. It still has all real numbers. And you don't have to write it all three ways there, all four ways I've shown. But you have to say it goes forever up and forever down. Or I'm talking about the domain. It goes forever to the left, it goes forever to the right. Let's talk range. Range is the up and down part. I'm going to go ahead and do the range for the green one first. The range is the up and down values. It's easier to see the range on this one because it's definitely going forever up and it's definitely going forever down. I'm going to write a lot of the same stuff that I just wrote. I'm going to write negative infinity, less than, make sure you're putting a y for the range, Or, instead of the y, since we're not actually writing an equation that has y in it, we could write g of x. All the same ways I wrote above, except that I need to have a g of x or a y in the middle of that. Does the red one also go forever up and down? Definitely a different shape, but it also goes forever up and forever down. So I can write any of those things I wrote up there. Except that we're not talking about x's, we're talking about y's, or f of x. I could write it this way. Looks exactly like the domain when I don't have to put in my y or my x or my f of x. That's why we would always make sure we specify whether we were talking about the domain or the range. Let's give it that fancy R. When I write it in class, sometimes I get sloppy, and I write that. And then I got people thinking that I said TR. I did not say TR. It's still a fancy R with two legs on it. Okay. I think enough about domain and range. Let's talk about, if you're trying to get another mathematician to draw the g of x graph, what key information would you give them as clues? You cannot tell them the coordinates as clues. You can't say it passes through 0. You know what? I think I'm going to talk about the straight line before I talk about that one. I'll come back to this. Same exact words here. You are to use your best vocabulary as though you met a famous mathematician and you're trying to impress them. And I'm going to talk about it, and you're going to write it down when you get there on your assignment. So if I talk about the red one, the straight one, I could say it's a straight line. I could say it's linear, but there's a whole lot of straight lines in the world. I would want a little bit more than that. You might talk about its intercepts. You might talk about its x-intercept. Where does it touch the x-axis? In this case, you might say it has an x-intercept at 6. They specifically said you can't tell me coordinates. So instead of just saying it has the point 60, I would have to say it has an x-intercept at 6. It has a y-intercept at 3. I might say that it has a slope, which we talked about its slope on the first slide, I think. It has a rise of 1 and a run of 2. I think we might have written that down wrong on the first slide because each one counts for only half a square in this case. And it goes downhill. So I might say that it has a slope of negative 1/2. So that's going in the negative direction. What else could I say to describe what it is? We know other things about that line. We've talked about its slope. We've talked about its intercepts. We've talked about the fact that it's linear. Let's look at the curve one now. Okay. Again, I can talk about x-intercepts and y-intercepts, but if I just say that this is a cubic, there are so many different things you could say about a cubic, so many different places a cubic could be. So I would want to tell them some things about where it's going. I might say that it has a y-intercept at 1. I can't tell exactly without giving the coordinates of the point where its x-intercept is. Its x-intercept is actually at 3.098. if I didn't have numbers given to me, I wouldn't be able to describe that exactly. I should talk about the fact that it is falling on the right, rising on the left. I might talk about it has, I can't say max and min. It has a maximum value of infinity and the minimum value of negative infinity. But I might say it has what they call a local maximum, a high place in the middle at about 3 3/4. It has a low place on its y-axis at the y-intercept at 1. That would give us a rough sketch. When we were in Mod 5, we also talked about end behavior, and I intended to put an end behavior problem in the middle of this thing, but I stuck it at the end so I can talk about it now. Here we go. Use infinity notation to describe the end behavior of each function. And basically, when we do infinity notation, we are talking about as x goes forever in the positive direction, what is happening to the y value? Or in this case, the y value is the f of x. So we're saying as x goes forever in the positive direction, is the y going up or is it going down? Looks like we're going down here. So f of x is going down to negative infinity. And as x goes forever in the negative direction, looks like I'm going up forever. So I'm going to say my f of x goes up to positive infinity. Now, I know that a lot of textbooks switch those around. They first state the negative infinity because they think going from left to right across the page is fine, is better. And either way is okay as long as those statements are there. It's just that if you are looking at something where somebody else has already written this part down for you, you better look carefully. When they say as x goes to positive infinity, they're talking about as we go to the right, up or down. When they say as x goes to negative infinity, we're talking about as we go to the left, up or down. Let's look at g of x. G of x, as x goes forever in the positive direction, what's happening to the y? Up or down? So as we go forever in the positive direction, looks to me like it's going down to negative infinity. And then I can say as x goes forever in the negative direction, what's happening to my y? Is it going up or is it going down? As I go as far left as the green one can go, which I don't see it going forever, but none of them go forever. I don't even see it going to the edge of my graph because it's rising too steeply. But it's going up to positive infinity. There will be cases where both ends go to negative and both ends go to positive. If I looked at a quartic, I would have to say both ends are going up to positive infinity. If I looked at a parabola, I can either have both ends going up or both ends going down. We talked about this back in Mod 5. If the degree is even, both ends are going the same direction. If the degree is odd, one end's going up, one end's going down. I also know, let's go back and look at this one again. If I wanted to know about this one and I'm describing it, it would be a good thing to be saying it goes down to negative infinity on the right. To describe that end behavior we just did might be a good way to put this in here. In fact, the fact that it's going down on the right for both of those, you could say they have a negative leading coefficient. The fact that both of these shapes have one end going up and one end going down, you could say that they have an odd degree. Those are all things that could be part of your description of each function that you've shown. There's probably a few more things as we get further along that I might need to talk to you about, but this covers most of what you'll need to think your way through as you're doing the first 2 or 3 of the comparing functions assignments. I'll keep posting this video, probably add some more stuff in writing when I feel there's something else we need to think about. But it should all be things we already know. We're just figuring out how to put them in writing. These are good practice for the state testing, which is probably not going to be happening because of the school closures and the social isolation. But I have a feeling they're going to make up for that by making juniors and seniors both take the CASP exam next year. We'll see. Your final exam, because you won't be at school for your final exam, we're not going to be just giving you some multiple choice thing. I don't know for sure what it looks like yet, but if you get a final exam and it's at home, it's going to have to be one of those things where you have to do some explaining what you're doing. We're not just putting out there something where you can all share the ABC answers. You're going to have to prove that you know, and then the teachers are going to have to take their time grading and make sure you're not copying from somebody, not using the exact same word someone else is using. Don't know yet. It's another 6 weeks before we get there, 7 weeks before we get there. And we're just starting to think about, now that we know school's closed for the remainder of the year, what are we going to do? We don't know yet. Okay. Again, as always, email me, call me if you're having problems with this.